Family and Marriage Counseling. Unit 4. Theories in the Psychology of Family Relationships. Introduction. General Systems Theory, GST, represents the fundamental and modern perspective on viewing and studying the family. Systems theory has roots in Gestalt psychology, which holds that the whole is greater than the sum of its parts. Key figures include Max Wertheimer, Kurt Koffka, and Wolfgang Köhler. They established that analyzing parts alone cannot fully explain the whole's function, a principle foundational to systems theory. We will present systemic principles relevant to families: basic unity, system change, viability and growth, open and closed systems, system boundaries, homeostasis, feedback, single outcome, and interconnectivity. The principle of basic unity views the whole as a vast system composed of subsystems. System change implies a system is more than just consistent components. The general systemic principles include the principle of basic unity, system change, viability and growth, open and closed systems, system boundaries, homeostasis, feedback, a single outcome, interconnectivity. Basic unity: the whole is a vast system composed of subsystems. System change: not just consistent components. Character and properties can't be understood by parts alone. Character and properties are influenced by parts. Changes reshape the system. Principle of fundamental unity. This principle states that the comprehensive whole is a single, immense system that can be viewed as consisting of any number of specific subsystems. System change. The system is not an assembly of consistent components. Thus, the character and properties of any system cannot be known simply by knowing the nature of its various parts. However, the character and properties of any system are affected by each of its parts, because when the relationship between its parts changes, the entire system is reshaped. Viability and growth. Healthy systems maintain themselves to stay alive. A social system survives by changing, repairing, and creating balanced conditions while preserving its distinct connections. Open and closed systems. Distinguishing between them is crucial in family system dynamics. A system in transformation that only rearranges parts without producing new material is closed. Such change is first order, reflecting an open system. Open and closed systems are key concepts in family system dynamics. An open system exchanges information and energy with its environment, maintaining balance and adapting continuously. A closed system, however, is isolated, rearranging its parts without producing new material, thus maintaining internal balance. Changes in closed systems are first order, reflecting a static state, unlike open systems that sustain themselves through ongoing input and output processes. Rather, it only leads to rearranging the parts of the system. This system is called a closed system, and therefore the change that occurs in this system is of the first-degree type, and this reflects the open system. A closed system is isolated from its surroundings, and maintains a state of balance within its boundaries. In contrast, an open system, constantly exchanging with the environment, adapts and aligns with inputs. System boundaries. Each system has boundaries that include all system relationships and events, differing from those outside or in another system. Homeostasis. Each system maintains itself and stays balanced, known as homeostasis. This regulates behavior within required boundaries and adapts to inputs. System boundaries. Every system has boundaries that encompass all relationships and events within it, differing from those outside or within another system's boundaries. Homeostasis. Each system maintains itself and keeps balanced, known as homeostasis, regulating behavior within required boundaries. Feedback. Feedback helps maintain stability. When out of balance, positive feedback increases deviation, while negative feedback corrects or stimulates to restore stability. Homeostasis is the property of maintaining balance. Feedback helps maintain stability. Positive feedback increases deviation, while negative feedback corrects it, restoring equilibrium. Negative feedback is crucial for change, as it informs about dysfunctions. Positive and negative are not used in their usual sense. Feedback is how the system stabilizes. When the system goes out of balance, positive feedback amplifies deviation, while negative feedback corrects or stimulates to restore stability. Thus, negative feedback restores equilibrium. Therefore, negative feedback on dysfunctions is essential for change. Positive and negative aren't used typically. Open systems handle inputs more flexibly than closed ones. Mechanical systems have fixed input-output paths. Thus, negative feedback corrects the imbalance and restores the system to equilibrium. Therefore, information about the dysfunction and malfunction of the system in the form of negative feedback is essential for change to occur. Note that positive and negative are not used here in their usual sense. An open system is more flexible than a closed system in handling inputs. In mechanical systems, inputs and outputs follow a set path, producing one outcome. In less mechanical systems, the outcome can be reached through various paths. If one path is blocked or a component fails, alternatives exist. This is equifinality, where different processes lead to the same result. Under pressure, the system may focus efforts on a single point or distribute pressure across the system. The latter allows the system to handle more pressure by mobilizing all forces. The system must be well structured for good internal connectivity. Different methods can achieve the same goal. Equifinality means many processes can lead to the same results or outcome. Under pressure, the system may focus effort on a single point capable of bearing the load. Alternatively, it may distribute pressures across the system. In this case, the system withstands more pressure by mobilizing all forces to share the burden. The system must be well structured to ensure good internal connectivity. The system may also choose an alternative approach, which is to distribute the pressures across the entire system. Clearly, in this latter case, the system can withstand greater degrees of pressure, because it will mobilize all forces and rally them to play their part and share in the burden. The system must be well structured and built to ensure that there is good internal interconnectivity,